Most people think chemical engineers just work in a lab, mixing chemicals all day. That's completely wrong. And in this video, I'm going to show you what we actually do, because nobody explained this to me before I started university. Welcome to Chemical Engineering Simplified, the channel where we break down complex engineering concepts into plain language. If you're a student, a professional, or just curious about this field, you're in the right place. Let's get into it. Here's the thing. Chemical engineering is not about chemistry in the traditional sense. Yes, we use chemistry, but we also use physics, mathematics, biology, and economics, all at the same time. The core question a chemical engineer asks is this: how do we take raw materials and turn them into useful products, efficiently, safely, and at industrial scale? That word, scale, is everything. A chemist might make 10 grams of a compound in a lab. A chemical engineer's job is to figure out how to make 10,000 tons of it per year without blowing anything up while making a profit. Let me give you a real picture of where chemical engineers work and what they do there. Refineries and petrochemicals. This is the most traditional path. You're designing or operating processes that convert crude oil into fuels, plastics, and chemicals. It's massive scale, high responsibility, and one of the highest paying sectors. Pharmaceuticals. Here, chemical engineers design the manufacturing processes for drugs. Not the molecule itself, that's the chemist's job. But how you make 1 billion tablets of a drug consistently, with zero contamination, that's chemical engineering. Food and beverages. Yes, the process that turns wheat into pasta or ferments beer, chemical engineers are behind that at industrial scale. Semiconductors and electronics. This is the fastest growing area right now. Chip manufacturing involves incredibly precise chemical processes: etching, deposition, cleaning. Companies like TSMC, Samsung, and Intel employ thousands of chemical engineers. Energy and sustainability. Hydrogen production, carbon capture, battery manufacturing, biofuels. The energy transition is being engineered by chemical engineers. And that's just 5 sectors. There are dozens more. So what does an actual workday look like? In the morning, you might be reviewing process data from overnight plant runs, checking temperatures, pressures, flow rates. Something looks off on a heat exchanger. You investigate. In the afternoon, you're in a meeting with the operations team, discussing why yield dropped by 2% last week. 2% doesn't sound like much, but at industrial scale, that's millions of dollars. Later, you might be running simulations in software like Aspen Plus or HYSYS, modeling a new process configuration to see if it's more efficient. This is the job. It's problem solving, data analysis, collaboration, and occasionally, yes, going into the plant with a hard hat. Now let's talk money, because this matters. Entry-level chemical engineer, $65,000 to $85,000 per year in the US. In Europe, roughly 45,000 to 65,000 euros. In the Middle East, particularly Saudi Arabia and UAE, salaries can exceed $100,000 with housing and benefits included. With 5 to 10 years of experience, you're looking at $90,000 to $130,000 or more. Senior process engineers and plant managers regularly exceed $150,000. The career path typically goes graduate engineer, then process engineer, then senior engineer, then engineering manager, then plant director or technical director. And if you go into consulting or move to finance with a chemical engineering background, the ceiling gets much higher. So, chemical engineers don't just mix chemicals in a lab. We design the systems that make the modern world run. From the fuel in your car, to the phone in your hand, to the medicine you take, there's a chemical engineer behind the process. If you found this useful, subscribe, because we're just getting started. Next video. How distillation actually works. Explained simply. See you there.